In thermodynamics, we often study the behavior of physical systems and their interactions with the surrounding environment. To understand these concepts better, let us start with the basic definitions. Let us define the system. It can be as small as a tiny volume or as large as an entire biscuit factory, or even the earth itself. The system is separated from its surroundings by a boundary. So basically, system means anything, any matter which you want to study, which you want to analyze, is known as system. For example, I have prepared a samosa, which is a fried product, and I want to study its interactions, energy interactions with its surroundings. Right. So here the system is samosa, or the area which I want to study. Say I want to study this much of area. So this much of area will be analyzed, and this much of area will be known as system. And I have created a boundary around it, uh, which separates the system from the surroundings, right? So now the question is, what are surroundings? Surroundings are everything external to the system. It can be the building, it can be the atmospheric air, uh, it can be any object, any substance with which the system interacts, right? There will be an interaction. And one thing very important regarding this is that the surroundings serve as a reference point for the system and are often used to quantify changes in the system. Now let us define what is thermodynamic boundary. A thermodynamic boundary is a hypothetical surface or interface that separates a thermodynamic system from its surroundings. Suppose I have a system. Suppose this is a system, right? And I want to study the energy, transfer of the system with its surroundings, and here it is surrounding, right? And the boundary is a hypothetical surface. Suppose I draw a dotted layer around this food, and this will represent the boundary of this system. Now the question is if the thickness of this boundary is negligible, approximately equivalent to 0, then how could it prevent the mass transfer in case of the open closed system, or even the energy, it prevents the energy transfer uh, from the isolated system? How could this be possible? The answer for this is that the thickness of thermodynamic boundary is not a physical property, right? That can be measured in units of length, and in an isolated system, the matter cannot cross the boundary, right? The mass cannot cross the boundary because of its nature, because of the nature of the system itself, not due to the boundary. So it is this system, actually, the nature of the system, which will decide whether the mass, there will be the mass flow or any kind of energy flow, temperature flow, it depends on the nature of the system itself, not the boundary. Boundary is just a hypothetical surface with or the interface which separates the thermodynamic system with the boundary. Now let us discuss the open system. An open system allows the exchange of both energy and matter with its surroundings. Let's discuss this open system with an example of samosa processing. After preparing the samosa, frying is done. Frying is performed, right? During frying, two things occur. First, mass transfer occur. Second, heat transfer occur. Let us discuss them one by one. When we dip the raw samosa into the hot oil, right? Due to the heat of hot oil, the water present in the samosa vaporizes and escapes to the surroundings, right? And the oil takes the place of the water. So oil moves inside the samosa and water moves outside the samosa. So this is how the mass transfer occurs while frying a samosa. Um, while coming in contact with the hot oil, the raw samosa gets heated up. Its temperature rises, and as I already told you that the oil gets impregnated into this samosa. So the stuffing of the samosa, its temperature gets rise. So this is how the heat transfer occurs while frying. Now, why do we want to study this system samosa? Here, our system is samosa, and we want to analyze its energy interactions. Basically, we want to, cook a raw samosa into cooked samosa. Basically, we want to change the white color of samosa into the brown, right? And all these things occur because of some chemical reactions. And these chemical reactions occur only because of these energy interactions, mass transfer and heat transfer, right? So this is the best example of an open system. Now let's continue with the closed system. A closed system permits the exchange of energy, but not matter with its surroundings. Again, let's take an example of samosa to understand the closed system. Now we have fried the samosas and we have hot samosas with us, right? Now I have stirred my samosas into a vessel which is airtight, right? So now I want to observe this system. This is my system now. This vessel is my system. And I want to observe this system. And I want to know which type of interactions occur. So after some time, I came to know that the temperature of the samosas has fallen to the same temperature that of its surroundings, right? But there was no change in the weight of the samosa, right? Because the vessel was airtight, and vessel only permits one energy interaction, that is the heat transfer, right? So this is the best example of the closed system related to foods. Now we are left with the isolated system. An isolated system does not allow the exchange of either energy or matter with its surroundings, right? So after preparing the samosa, after frying the samosa, we have the hot samosas with us, right? And if instead of storing these samosas in a simple airtight vessel, if I am storing this in the insulated uh, bowl, right? And after some time, if what I find, the samosas, the temperature of the samosas was the same. Uh, as it was after the fry. So there was no change, no change in temperature, right? And there was no change in the weight of the samosas. So this implies that the isolated system is that system which does not allow any kind of energy interaction with its surroundings, right? Um, so I have explained all the systems related to the foods. Hope you understand this thing.